Well, today I'm not going to talk about weather forecasting. I'll talk about climate forecasting. And I am proud to say that there is a protest gathering against what I'm about to say right now in South Whidbey Island. Some people do not think I am extreme enough. So anyway, I'll let you judge. It's just perfect. Anyway, the talk I'm going to give today is global warming over the Pacific Northwest, separating facts from hype, and there's certainly plenty of hype going around. There is a great deal of contradictory information about global warming, and including its influence here in the Pacific Northwest. You know, there are some environmental groups that have proposed that global warming has already profoundly affected things around here, particularly precipitation, suggesting precipitation has already become more extreme here in the Northwest. And of course, Seattle's ex-mayor, who was challenged in all things dealing with snow, and he's no longer mayor because of that. He wrote an op-ed piece suggesting that the snowpack in the Cascades is in fact declined by 50%, and that was probably due to global warming. And media headlines have become more and more scary. And this is just from Time magazine over here. In contrast, on the other side, others hold that the lack of warming during the past decade and a half indicates that global warming is no threat. We don't have to worry about it. And some even suggest that the Earth is cooling. And one of them is from around here, unfortunately, Don Easterbrook at Western Washington, who has suggested that we're about to go into a period of global cooling, and that's what we should worry about. And there's other local media outlets and whatever suggesting that global warming may be a myth. Some people ask, how can scientists predict climate 50 or 100 years from now when we can't get next week's forecast right? I mean, that's a fair question, okay? But on the other hand, there are thousands of scientists from around the world who've written a series of reports indicating that global warming is an imminent and important threat to mankind. And these reports, are done by the Intergovernmental Panel on Climate Change, IPCC, bringing together the expertise of scientists throughout the world. The global warming debate, for good or for bad, and I think probably for bad, has divided into what I would characterize as almost tribal warfare, with two sides, going after the other. In fact, I'm here today, and there's these guys down in South Whidbey. I don't know. They don't think what I'm going to tell you is extreme enough. So the question is, what is the truth? What is biased and wrong? What do we know for sure? What are the uncertainties? What's going to happen here in the Northwest? Are we doing anything, and what needs to be done? Okay. How do you like that? Okay. I'll cover all that in the next half an hour or so. You're going to get your money's worth here. Now, the problem is pretty clear, that greenhouse gases are warming. And this figure over here shows you the CO2 from 1600 up into the future. Here's right now. And clearly, CO2, which is a primary greenhouse gas, is increasing rapidly now. And this figure shows you in various colors because we're not sure exactly where it's going to go. One thing I want to make sure you know, and you probably do, that greenhouse gases warm the Earth. We're pretty sure about that. And carbon dioxide is only one greenhouse gas. Actually, the most important greenhouse gas is water vapor. That is the key. That is the most important one. But there's others like methane, nitrous oxide, and others. There's a series of greenhouse gases. Now, believe it or not, we understand the greenhouse effect. And I'm not going to go into detail here right now, but you've all heard this. Solar radiation comes in, it predominantly warms the surface of the planet. The planet radiates predominantly the infrared. That infrared radiation it doesn't pass through the atmosphere. The atmosphere is not transparent because of the greenhouse gases, which send some of the radiation back to the Earth. This goes back a long way. Arrhenius did a paper on the subject that actually was quite good back in 1896. In fact, there was some papers going back even earlier than that, in which people basically got the story right. And the bottom line is that essentially the atmosphere, and particularly the greenhouse gases in the atmosphere, act like a blanket. More blankets make you warmer, okay? It's really as basic as that. If you're one of these people who don't believe that greenhouse gases will warm the planet, then you're going to believe that more blankets are not going to warm you up at night. The question is, by how much? That's the question. So on a basic level, we really understand what's going on. Now, how do we predict the climate in the future? Well, I'm a numerical modeler, so I'm very comfortable with this stuff. We predict the future effects of increasing greenhouse gases using climate models. That's the tool we use. Now, these climate models are sophisticated computer simulations that are based on the physics of the atmosphere. And they are nearly identical to the weather prediction models we use every day, that are tested every day. The weather models that are getting better and better. And you know they're getting better because virtually every major storm that has come to the Northwest in the last few decades, we have forecast correctly. Hurricane Sandy, we forecast that over a week ahead of time. So these models, they ain't perfect, but they're getting better and better. And so they're like the weather forecast models, but they have a few details like the gases in the atmosphere can vary in time. So as I said, they're good, but they're not perfect, and they're run on supercomputers, the fastest computers available. Now, the output of these climate simulations looks somewhat like this. It's a graphic that's based on a collection of these. This shows you the forecast of how the temperature is going to change near the surface in the year 2100. This shows you the change in temperature over 100 years, and the dark reds indicate warming and less warming to the yellows. And you see, there's general warming going on. Okay, so this is based on a scenario that assumes mankind is not going to decrease the rate of increase of putting greenhouse gases up there. Now, the thing I want you to see from this is global warming is not globally uniform. Really important. Look at this chart. The Arctic warms up more than the rest of the planet. And that's true for a number of reasons, among them the fact that sea ice will be melting. The continents warm up more than the oceans. The eastern oceans warm up less than the western oceans. And in general, dry areas like the southwest United States will get drier, and wet areas like in British Columbia will get wetter. Those are general conclusions. Global warming is not uniform over the globe. Very important. And I just said that. But one thing I have to make clear, there is uncertainty there. Lots of uncertainty. First, we're uncertain how much greenhouse gases we'll put in the atmosphere. That's true. But there's also uncertainty in the models. And roughly, for the global temperature change over the next 100 years, roughly or the doubling of the amount of CO2, roughly the models predict that the globe will warm up by 1.5 to 4 degrees centigrade, in that range. And the amount of uncertainty for the local changes is even greater. So there's uncertainty for the global prediction, but then there's uncertainty on what's going to happen locally. And interestingly enough, the uncertainty has not decreased over the last 20, 30 years as our models have gotten better. What happens is we keep adding more details, and that gives us more and more uncertainty. So the uncertainty really hasn't changed very much. Well, the question that most of you are asking is, what about global warming in the Northwest? Now I'm going to say the stuff that's going to be controversial while these guys are protesting down in South Whitby. It appears that there has been relatively little human-caused warming in most of the Northwest, particularly from the Cascade Crest to the west. And this makes a lot of sense. It makes a lot of sense that we haven't seen much global warming yet, because our weather is controlled by the Pacific Ocean, and that is an eastern ocean. And if you remember, I told you, and I showed you on those climate simulations, that the eastern oceans warm up less than the western oceans. The eastern oceans warm up more slowly than almost any place on the planet. Our weather is controlled by the Eastern Ocean, and so we're warming up less. But although global warming is going to be weaker and delayed here, by the end of the century, it's going to happen here